it's complicated. Multi-step, flip to the back. Farmer has 200 meters of fencing. Wants to fence off a rectangular field that borders a straight river. What dimensions of the field will give the maximum area? So, again, let's think about it. We have our river. If we're going to board off against the river will make one side, assuming that these things can't cross. Whatever he's trying to board off can't come through the river, so we only need to worry about three sides. We have a length, we have a width, we have a width, and that entire thing is 200 meters. What dimensions will make the maximum area? As soon as I see the word maximum, I know that's vertex. I think about a max or a minimum, so I want to think about vertex mode, which means complete the square. That is one way to solve it. There are other ways, but that might be the best use of the skills that we have. I need let statements to help me set up how I'm going to figure this out. So if I think about that, I'm going to let, let's say L, it could be W, it could be whatever. Let L be the length. Of the field. If I know W, and I'm just going to set this up first as 2, and we can do it as 2. I might have set it up as 1 to begin with, but again, if you don't see how to do that, set it up as 2 to begin. Let W be the width. So, if we think that that whole thing is going to be 200 meters, there's our first equation. 2 W's, 1, 2, plus a length is going to equal 200 meters. I'm going to rearrange here for length, and the reason why I'm going to rearrange is because as soon as I see a rectangle, and I want to know the maximum area, I know the area of a rectangle is length times width. So I want my maximum area, and I'm going to use this to actually change my two variables into one. So let's rearrange for length. Okay, so our maximum area means we're going to try to treat this as vertex, which means we are probably going to be completing the square to get to vertex form. Okay, length. Oh, I've got a length now. My width. Oh, I've already got a width. And now I have that. So, distribute. Salt Bae, sprinkle that in. Let's rearrange. Always, always, always. Is there a common factor? Completing the square. Oh, yeah. Remember what we do here. We're going to take that. That's what color do I use usually? We're going to take that, negative 100. We're going to divide it by 2. And then we're going to square that. 50 squared, 2,500. That goes inside the brackets. we need to make a perfect square, which means we want that, because that will become perfect square trinomial. Get the negative 2500 outside the brackets. Distribute selectively. Negative 2500 times negative 2. We're probably going to want this. Again, remember that that is going to be the perfect square trinomial of w minus 50. That entire thing becomes w minus 50 all squared. And now we have vertex form. What was the point of that? The point was we have a solution for w. We've solved for w. So from there, remember the vertex is 50, 5,000, which means that w is 50, as I write it outside the camera. If w is 50, we have just solved the width. This is the maximum. That's the maximum area that's included or enclosed by 200 meters of fencing on 3 sides. The width is 50. So we can go back here, sub width in to actually find our length. We just found the width of 50. So what does that tell us the fencing is? 100 meters by 50 meters. That makes up 200 meters fencing total and is the maximum width. So, what dimensions of the field? Therefore, the field would need to be field will need to be 100 meters long by 50 meters wide to produce the maximum area. You might remember that to make the biggest area possible with a select limited amount of perimeter, when you're only doing 3 sides, it will actually be a rectangle as opposed to a square when you have 4 sides, and the length will be double the width. Here is using our skills of completing the square. Boom. Okay, that's day 2 of applications. Give it a try. Go for it. You're doing great.